Hi, welcome to the presentation for my final project for the Illinois Masters on Data Science CS410 course Fall 2018. On this project, I'm going to try to give you some insights on how to start tackling the problem of fake news on news websites. My name is Danilo Canivel and I hope you enjoy the content. So here's what we are going to do. Here you have my repo. You can go to github.com Canivel and look for CS410 fake news detector. And you're gonna find some folders over there, and you can see there is a folder called fake news classifier, where you're gonna find all the code and some notebooks related to my fake news classifier. It's very simple, it's not that complicated. I didn't architect it to be a library, not yet, because I'm in the research of this problem before to try to create some more robust deployment of it. So you can run it script by script and you're gonna have the same solution that I have. To start this, we need some data, as always. So basically what I did was look in Google for fake news datasets, and Kaggle it's the first one that appeared. So in Kaggle you're gonna have two datasets. The first one is a competition. You can come to Kaggle, see fake news, and then you go to data, and the data is gonna be available over here. You can download both files. We're gonna need both files. We're gonna need the test if you want to create the submission to Kaggle. And the other one is this one. It's from a user, Jeruvica. So you can go to this address. Both addresses are on my repo. So you can go to the main page of my repo. You're gonna see here. It's not only that, because with only those two data, we're gonna have a very unbalanced data set in the end. I'm gonna explain why. So we are gonna have to scrap some data from, let's say, real news, because we are gonna fall on the amount of real news that we need to tackle this problem. So let's take a look on the data before we start processing and training it. So here I have an empty notebook, and it's gonna be pretty fast. I guarantee to you. We're gonna have here. Let's bring train Kaggle as PD read CSV. I have it already on data Kaggle train CSV. You can use the same folders if you want to use my repo. You can try to use the same folder so you don't need to change a lot of stuff. So, and this another one is a train, let me call it train fake. Okay, go. I'm gonna show you why. I call this one, that's data CSV, I call it a fake CSV. Right, I'm gonna load all of those. And let's take a look at it. So train Kaggle info. I'm sorry, info. So we have ID, title, author, and text in a label here. We have 20,800 observations on it. So you can see here that is a label, and the label, train Kaggle, the label, dot value counts, so we can see the distribution of it. You can see that we have almost a very balanced data set here. So the unbalanced problem that I was talking about start when we look into this guy. So this one we have much more columns, much more features, and the label it's called type here. So let's take a look at it. Train fake dot type dot value count, and you can see here that it does not have real news. It has BS news, bias, conspiracy, hate, satire, state, junk, and fake. So, on my point of view, let me be very clear here. My point of view is that real news cannot be biased, cannot be a conspiracy theory, cannot be hateful, can't have any feelings related to it. Can't have, because feelings is an opinion. So real news is fact over fact. So what I did is get this data from the, the data set from this data set and call it all fake news. So doing that, you can see that, let me show you the shape of this. You can see that you're gonna have more 13,000 fake news here. So just to be sure here, 1 is the fake news and 0 is the reliable news. Yes. So you're gonna have more 13,000 over this guy. So you're gonna have 23,000 fake news and 10,000 real news. That's pretty bad. That's very unbalanced. So to deal with this, what I did is to scrap some data from some websites that is supposed to be reliable. So for you to get the data from their APIs, first we need to find what APIs to get it. So to find out APIs for news, I researched it and I found out on Wikipedia news APIs. And here's it. And here you can see there is a lot of stuff here. And the only ones that works, it's at least for me. I didn't try all of them. I tried a couple of them, but the only one that works for me was New York Times and The Guardian. So I got those two. So to get the data from these guys, you need to go to their website. You can go to my repo. I have the direct link for you to create a key for it. So you can go to this website and create a key for it. It's pretty straightforward. Just fill up and create a key for it for developer. And the Guardian, same thing. And after it, you go see on my repo there is two files. One color New York Times Spider and the other one color the Guardian Spider. Yes, here's that. So what they will do is go backwards in time. It goes from today and backwards, and you can go into it and decide how many you want it and how many news you want it. It's all documented on it. And you can go, basically you can go here and get the number of pages you want it. So for example, and run it. So before you run it, make sure that you have the data, the MongoDB created, because I saved all the news because it's coming in JSON format. So I decided to save it all in a NoSQL. So you create a MongoDB database called fake news in two collections, one TG article and another one NYT articles, and that's it. You run these both guys, they will save there a lot of news. So after you guys save all this news, what we are going to have it, what we are gonna have to do is to clean up this data because it's gonna be full of stuff. So you can run this script. You see that is a script. I don't have functions complications on it yet. So you can go direct to it. You're gonna connect to Mongo and it's gonna download it's gonna fetch all the articles from both collections, and it's gonna convert it to pandas, and after it I'm gonna rename the columns to both datasets match each other. I'm gonna merge it, and I'm gonna save it to a CSV. Pretty clean, pretty straightforward. So just run this guy. It's gonna save you all the MongoDB data to a CSV. After it, you have to run the dataset builder. The dataset builder is gonna get the train data, the fake data from Kaggle, plus the one that we collect from the real news websites. Let's say like that. We're gonna first fill up some empty default value. I call it no author, no title, no text. I'm gonna do this for all the data sets. And I'm gonna keep only the columns for title, author, text, and label because it's the only columns that we have on the train from Kaggle. So the other stuff, it's good to have the data over there because someday you can find a new data set, you can merge it, and you can have more insights on it. But since we have this Kaggle that only has the title, the author, and the text and the label, we need on these features for now. So here's gonna clean up those three data sets, gonna merge them all three, and gonna save in a final data set over here. So after you do this, you are going to have your data ready to run. So then we are gonna move to the notebook. It's easier because I have a training pie over here. Yeah, you can run this. It's the same thing as the notebook. So we're gonna do the same thing. And you can choose here if you want to run a Kaggle submission or not. So let's go to the notebook. So in the notebook, we load some libraries. Basically, sklearn, pandas, scipy, numpy, pickle, word batch that I'm gonna use to extract some features. And the model that I'm gonna use is gonna be from YGBM classifier with a binary object on it. I'm gonna show to you when we get there. So first things first, we create a normalize function here that we are going to use to clean up the text, lower it up, and remove some stop words from it, remove some bad characters from it. And then what I did is to load the data. You can load the data before this, there's no problem. It's just a matter of liking what to do first. I like to have my functions first. So after it, I say some variables with the size of the train in the test because and remove the and save the labels in a y variable. That it's pretty default how people do that stuff nowadays. So we need to save this because we're gonna merge training tests to run our pre-processing of both data. We need to have both data to be pre-processed together. So after it, I visualize a little bit of the train title to see what kind of text that we have there. And you can see that we have some tests for this most political environment. So we have some universities. Uh, Here I have some on the test data set. You see that looks like pretty different. You see here we have Trump, here we don't have Trump, but probably have Hillary. Yes, we have Hillary here. Comey, see, looks like they are pretty related. Trump, Russian. So after it, I do some cleanup, remove the labels and the IDs from the test. We don't need that. We already saved that before. And I append, here we append the training test data. I run the field nuns again just to be sure. Be sure to deal with your non-variables, non-data. So after I encode the author is a category. So we create some category column here for the author. And then I steam the title. So to steam the title, so it's gonna steam all of it. And after we steam it, I run another one on the estimate test to see if it's different, and you see that it changed it a lot. So it looks like it changed it a lot. So I created a map for the authors because I'm gonna have to use that for the client side when some author is requested, and I use the same author if it's already on our category, otherwise create a new author. And drop it, the columns that we are not using, title, author test, because we rename it to estimate test, estimate title, and author cat. So after it, we run the word batch. Word batch is gonna run word back and all the data, and it's gonna create any grams of 2 and with the weights between half and -1 and IDF of 10, and it's gonna term frequency. I choose log because it's gonna have less gaps between one and another, so it's gonna be more normalized. And here at transformation we run this word back, and then we get all these vectors and merge it in a single sparse vector here at the sparse merge using SciPy. And after it, we split back to the train test data. Here I call it X and X test just to not confuse it with the data sets. So here we have a vector X and an X test vector with the train data. And then I got the train data, the X one and the Y, and create a split between train and validation so I can do some cross validation with model. So here's the model, light GBM. It does some feature selection for us, so you can see that we have a lot of features. We have 16 million, yes, 16 million features, so it's gonna cut it to 64%. And I still keep it's unbalanced true because you have some difference between the amount of real news. Now you have more real news than fake news, so I keep it true, but since the difference not that big, it's not going to change that much, but it get a little better on the result. So, and I create another stop rounds of here I put 200, but the one that I submit to Kaggle I put 1000. So you can try both. It's not gonna change that much. After it, I run some scores to see how it was going. It was going pretty well. You can see here that we have a very nice F score and very nice accuracy. And the one that we can take a look after it is the precision score. You can see that it drops a little bit, not much, but it drops a little bit, probably because we overshot our fake news calling on the data from Kaggle, and real news, we call everything real news on the other one. So I probably didn't show to you where I did that. I'm gonna come back to it. You did that over here. You see, you call Kaggle fake label 1, and then we do the New York Times and the Guardian label 0. So we call it one is fake and the other one is all true. And after it, we save the model for our deployment. We save the transformation because we need to run the transformation before the training, before the prediction. on our deployment, so we need that save it. And here I run the Kaggle submission just for testing on Kaggle. So when I test on Kaggle, here's my submissions. You can see clearly that was doing pretty well just with the simple model. You see, every single one that I run it was over the first one. So it's just a simple model. If we assemble it, we're probably gonna get 9999999. Here, you could probably gonna get a very nice result here in Kaggle. But that doesn't solve the overall problem. I'm gonna show you why. So let's try our fake news classifier. You can go to my repo, and at the bottom of the README you're gonna find three links. One is for the client example that I created with React. The code's over here, and the other one is endpoint that you can use to send requests. Is a post request, so it's not going to open here. So you can send a post request to it. To see how you're going to send the post request, you can open the docs here. It's very simple. It's author, text, and title. Execute here just to see if it's working yet. You return your prediction and the fake rate. Alright, so let's try it out. Let's open up the client. We put this to the right. Let me open up the client here. CS410. Alright, here we have the client. We put it in here. Now let's open, I have in here New York Times. Let me see. Okay, so let's see what happens when we try New York Times news. Remember that we scrap a lot of news from New York Times, so our model probably gonna find out some pattern from New York Times news, and probably it's gonna be real news. See, it's a very low rating of fakeness, so it's pretty reliable because our model identified this. That's what is going on over here. You can see the same thing is gonna happen with the Guardian. It works for a lot of cases. You saw at Kaggle, it got a very nice result, but what he's doing is not only check for a pattern of real or not real or 1 or 0. He's checking the same thing if he recognizes the pattern of the text that we are inputting here with the pattern that he has on the model saved. So what it does is recognize the source of the news. And that's a very nice thing, because you can imagine that the source of the news can be, you see, can be something that you can use for sure to say if it's reliable or not. Imagine that you have a text. When you put the text over there, you are visiting a random website. You want to check if this random website, that news that the people are putting over there, is real or not. So you can put it over here, and if you have a lot of other websites crawl it, like CNN, Fox, whatever, he can identify from where is that file, from where is that text, and if it's the thing is reliable or not. It's the same model. It's mainly the same model. So let's try this one. Did I update here? Yes, Virgin. Okay, we already tried this one. Let's try one from, for example, CNN. CNN is completely biased, same as Fox. completely biased. I'm not going into the matter of it, but you know what I'm talking about. And let's get this one. Let me stop this video. It's gonna start playing. I don't know why CNN does that every time they try
Jim,
to...
so far the president, I understand.
Oh God. Okay. Here he goes. Title. Text. I probably copy a lot of things that I shouldn't. No, it's okay. On the first line, let's remove the first line. I don't want to have this replicate. Okay, okay. Evaluate. So see? You see what I'm saying? Hey, it probably identifies some bias because remember that we got this fake news dataset from Kaggle and we call it the bias fake news. Probably is one of the things. And another thing is that the pattern of the news is different. Every media, every author, every editor from each specific journal or newspaper, they use almost the same language because it's like a brand. You know, people like to read New York Times because the way things are wrote over there. Same thing in the Guardian, same thing in CNN, same thing in Fox, because there is a pattern of how things are wrote. So I'm gonna do one more, and I think we are done for it. Let's try Fox. Okay. We can try to find some real fake news too. Let's see. You see? It's still unreliable, a little less, because I think they have a little less words, biased words over here and sentiments and everything. It's more like a talk. So you probably find out some patterns in the test that I have more close to the other one. Let's see now some fake news examples. Let's see this one. Okay, probably is this one. It said that it's fake over there. Let's see if it's fake on our system. Yeah, it's pretty fake. Alright, guys, that's it. Have fun playing with it. I'm pretty sure that it's gonna bring some good results, some bad results too, because it's far from perfect. It's far from an ideal solution for a broad kind of environment, but it's a beginning. It's a way to do it. I'm pretty sure it is. All right. Thank you very much for listening to it. Hope you enjoy it.